Welcome back to Applied Algebra and Trigonometry. Today we're going to talk some more about functions. And in a disturbing sign of the times in our country, mathematics also is divided. But today we are going to get real. For most of the course, we are going to be dealing with real numbers only. And yes, pi is a real number. It's just irrational. Let's talk a little bit more about the Cartesian plane. Often we think of the horizontal axis as the x-axis and the vertical axis as the y-axis. However, now that you know about function notation, you can think of the vertical axis as the function of x-axis, or t and f of t, or g and f of g, or x and g of x, or a multitude of other combinations. We need a better way of talking about these axes if we're going to keep changing the names. I have already mentioned these terms, but just to reinforce that in your mind, the independent variable is represented by the horizontal axis, and the dependent variable is represented by the vertical axis. We are going to use a name for all possible values of the independent variable, usually x, that make the value of the function a real number. But what is a real number? Well, it's easier to say what is not a real number. Anything not a real number, an imaginary number, or a complex number, which we'll get to later, okay, is anything that has a square root of a -1 in it. That is not real. That means the square root of negative pi is not real. It means the square root of -7,492 is not real, all because of those negatives under the square root, or in fact, under any even root. We'll get to that later too. What do we call all possible values of the independent variable? We call that the domain. And what do we call all possible values of the dependent variable? We call that the range. Now I have a little mnemonic device for you, a memory trick, if you will. Memory strategy is better for remembering the two different things. If you look at the domain of a king, the king's kingdom would be laid out along the horizontal axis, but in the middle of the kingdom there might be a mountain range. Okay, domain and range. So let's do a little bit of analysis. Let me rearrange the screen to keep our definitions in sight. During the next part of the video, I highly recommend that after I analyze each individual function, you pause the video and fill out this chart on your own piece of paper that you can keep in your notes. Of course, I hope you've been doing that all along. Let's look at the function f of x equals x. Is there any real value for x that we can insert there as the independent variable that will return an imaginary number, something that is not real? Well, no. The domain here is all real numbers. What if I added a -2 to this function? Would that change the domain? Could you put any real number in there and not return a real number from the function? No. The domain is still all real numbers. And if you use a real number as your independent variable, what can you return as your dependent variable? Is there any number, any real number that you cannot get? No. So the range is all real numbers, either for f of x equals x, or f of x equals x minus 2, or add, subtract, multiply, anything there. Your domain and range will be all real numbers. When is that not true? Let's look at another function that you might have. And I am going to erase that -2 there, so it's just easier to see everything. And let me move those over a little bit. Okay, if you have another function, g of x equals the absolute value of x, is there any real number that you can put in for your independent variable that will return a non-real number? Okay, so this is all real numbers for the domain. Okay, so you put any real number into the absolute value of x. Any real number for x. Is your range limited? Are there some real numbers you cannot get? Well, an absolute value always returns a positive number. So you cannot have anything less than 0, nothing negative. So in this case, your range is, and we still say all real numbers, but we put a comma in. And because we are talking about the range, we use whatever symbol for the function that we used before. So we have all real numbers, g of x greater than or equal to 0. Because you can put 0 in there. Just the absolute value of 0 is 0. It's not very interesting. And let's look at another function. Let's look at the function h of x equals the square root of x. Okay, now, is there any real number, or are there real numbers that we could put in for our independent variable, in this case x, that would not return a real number? Well, I went through this earlier in the video. The domain of h of x, if h of x is defined this way, is all real numbers as long as x is greater than or equal to 0. So we have constraints on our x now, because if it's less than 0, you have a negative under a square root, and that produces an imaginary number. So here we have all real numbers, x greater than or equal to 0. So now when we think about the range, we have to think about what we're limiting our independent variable to. If it has to be 0 or greater, can the function ever be negative? No. The smallest it can be is 0. It can be 0, right? So the range in this case is all real numbers, h of x greater than or equal to 0. And let's take a look at one more function in our chart. Let's look at k of x equals 1 over x. Right, I'm going to have to make this a little bit smaller here so I can fit everything into my chart. All right, so k of x equals 1 over x. Is there any value of our independent variable which will not return a real number? Well, now we're not just looking at imaginary numbers. What happens if x is equal to 0 here? What is 1 divided by 0? Well, that's undefined. We can argue about that, but in general, it's undefined. We're not going to argue about it, okay? We're just going to say we don't want that. So our domain is all real numbers where x does not equal 0, right? So if our x can be negative, it can be a fraction, it can be anything except 0, any real number except 0. So our range can be positive, negative, big, small, fractional. What can it not be? Let's see. Let's analyze this a little bit further. Let me make some room to do that. We already talked about what happens if you use 0 as your independent variable, and that returns nothing. Okay, so 0 is excluded, so let's look at 1. If we put 1 in for the independent variable, we get 1. That's a real number, so we can use 1. Right? What if we do a negative number, like negative 4? Okay, 1 over negative 4 equals negative 1/4. That's allowable. What if we plug in an extreme number? Say 10 would give us 1/10. Let's go ahead and do 1,000, or 1,000. Put it in for x, and we return 1,000. Boy, that's tiny. It's getting close to 0. If we put in a bigger number, it's going to get even closer to 0. Is there any number that can make it reach 0. What about a fraction? Let's try the fraction 1/5. Okay, that would give us 1 over 1 divided by 5. Okay, that's a division. To divide by a fraction, we have to multiply by the reciprocal, which is 5 over 1, or 5. Well, that got bigger. In fact, the smaller the fraction we put in there, the bigger the result. If we put 1,000 in there, the function would return 1,000. So that's making it get bigger instead of smaller. In fact, there is no number that will return 0 as the function. So our range is limited also to all real numbers, k of x, because that's what we call this function, does not equal 0. We can't get 0 by putting a real number in for x. Now let's look at our chart along with everything we've talked about so far about functions and domain and range. Considering our definitions and our analysis, there are two things we need to avoid. We need to avoid division by 0, and we need to avoid the square root or any even root of a negative number, because those, in this case, 1 divided by 0 will be undefined, and the square root of a negative or an even root of a negative is an imaginary number. So let's take a look at some more complicated functions, but we're going to remember to avoid those situations that are now at the top of the screen. Now, I have another mnemonic for you to use if you're having trouble analyzing a function. This is not perfect. It is not an absolute way to analyze a function, but it's a good way to get started to try to understand what a function is actually doing. Okay? And zone F numbers include 0, 1, a negative, and an extreme number. Try an extreme and try a fraction. So let's look at some examples of using these zone F numbers. I recommend you pause the video and try putting in a 0 for t, a 1, a negative, an extreme, a fraction. Here you can see the zone F numbers I have chosen. You could have chosen, after 0 and 1, different numbers. Okay? And in every case, I have returned a real number. But I'm going to go back and analyze this and see if maybe there's something that I forgot, that I didn't think of. Nope. I think pretty much I can say with confidence that the domain of the function a of t is all real numbers, and the range of a of t is all real numbers. Okay, so let's look at the function b of f, defining that as 1 over f minus 2.5. Pause the video and run through your zone F numbers. I also suggest you pause the video here and think about how I came up with my answers. As you notice, this is a little bit of a strange function because it has a decimal in a fraction. So I gave you two types of answers for each of these, either decimal or fractions. Take a closer look though, and you'll see that when you substitute a 1, a -3, or 500, I come up with a decimal approximation. I rounded those numbers. Now I ran through all of my zone F numbers, and every single thing works. So does that mean that our domain is all real numbers and our range is all real numbers for this function? No. Zone F numbers are a place to start if you're having trouble doing the analysis, but let's look at the function itself. Remember, we also have two situations that we want to avoid. We want to avoid dividing by 0. So when you're looking at your functions, if you have a fraction with the variable in the denominator, set that denominator equal to 0 and solve. So I'm going to add 2.5 to both sides. and I'm going to get f equals 2.5. If f equals 2.5, this blows up. I get division by 0. So in this case, the domain of our function is all real numbers except for this. F cannot equal 2.5. So what about the range? Well, if you plugged in an extreme number, you saw that it got very, very close to 0, but it will never reach it. So we now have the range as all real numbers. Function b of x does not equal 0. Please look back in your notes and take a look at k of x. Compare the domain and range of k of x equals 1 over x to the function b of f equals 1 over f minus 2.5. All right, pause the video and see if you can analyze the function c of t equals square root of 5 minus t and determine its domain and range. Some of you may have gone through the zone f numbers, and if you did, here's what happened. Now at this point in the course, I don't expect you to be able to do all of the manipulation of radicals that we're going to do later. But if you got the exact answers, this is what you should have come up with. Okay? If you used your calculator, this is an approximation rounded to the tenths place. This is an approximation rounded to the tenths place. And I imagine that for many of the numbers that you chose, that would have to be the result. And I chose my zone F numbers in order, 0, 1, negative. When I got to the extreme, look at what the calculator gave me. It gave me an error, a non-real result, because I was taking the square root of a negative number. But the question is, how extreme is extreme? We need to do a little more analysis. And actually, if you did this analysis first, you could have skipped all of this calculation. We have the square root of 5 minus t. And what's underneath the square root? 5 minus t has to be greater than or equal to 0. So if you remember how to solve inequalities, if not, take a look at the first chapter in your book. Let's subtract 5 from both sides. That gives us negative t is greater than or equal to negative 5. And now we're going to divide by negative 1 in order to isolate the t. Okay, but remember with an inequality, when you divide or multiply by negative 1, you have to flip the direction of your inequality. So t has to be less than or equal to positive 5. Let's see what happens if we put positive 5 in and find, as our independent variable, and find the function of positive 5. Square root of 5 minus 5, that gives us square root of 0, which is 0. If we put in a value less than 5, let's try 4. We get the square root of 5 minus 4 equals 1. Okay, here's another aside we need to talk about. Okay, aside from that, whenever you see a square root sign, it means the positive square root of whatever you are working with. I know some of you are saying, wait a minute, that's not true because square root of 25 has two answers. It's 5 or it's negative 5. Yes, 5 and negative 5 are both square roots of 25, but if you are given a problem or given a function in which you have the square root written, by writing it that way without a plus or minus in front of the radical, it means only consider the positive square root. Now, if you are in the process of solving a problem and you're working through it and you get down to say x squared equals 4, let's see, let me write that up here, x squared equals 4, and you decide to take the square root of both sides to solve the problem, then yes, then you have to consider both the positive and the negative solution. But this is not the process of you doing it. We're talking about when you are given a square root as part of the original expression, the original function that you're working with. Then only consider the positive square root. Okay, I hope you're still with me after that aside, but this is really where we were in our analysis. That the variable, the independent variable t, has to be less than or equal to 5, because if it's more than 5, let's say 6, or even 5.25, when you do this subtraction, you're going to wind up with a negative under the radical. So we cannot have that. We want to return a real number from our function. So if you started this problem by doing the analysis, whoops, let's get rid of that. All right, then you could have gone ahead and told me what the domain and range were. It is obvious from this that the domain is all real numbers t less than or equal to 5. So if that is the domain, what is the range? Okay, if t equals 5, we get 0. If t is less than 5, we get some positive numbers. If t is a lot less than 5, we get a bigger positive number. So we have all real numbers. C of t is greater than or equal to 0. If you're confused about the range, go back and look at my negative example when I plugged in a negative number in the function c of t. This lesson is more involved and longer than the ones you've had for the past few days. So I'm going to split this into 2 videos, but let me give you one more example for this video. Okay, the function d of t equals the absolute value of negative 4v. I'm going to let you go through the zone F numbers yourself if you want to. I'm just going to take a look at this. For the domain, will any number that I put in there, any real number, give me a non-real result? No. So the domain of this is all real numbers. So let's think about this. If I put in 0, I'll get 0. If I put in 1, I'll get negative 4? No, I'll get positive 4 because I'm taking the absolute value. In fact, is there any way to get a negative number? No. So what we have here is all real numbers, d of t greater than or equal to 0. An absolute value will always be positive. And just as an aside, perhaps we should add irrational numbers to this, to our zone F, zone FR, I don't know, maybe I'll have to come up with a different mnemonic. But if we put in, instead of t, if we put in pi, what do we get? Negative 4 pi, take the absolute value, is 4 times pi. That's the exact value. If you put it into your calculator, you'll get an approximate, but that's still real. So it still applies. The domain is all real numbers. So let me restate what you are supposed to avoid in order to find the domain and the range of a function. So in other words, id est, avoid a denominator that equals 0, or the radicand of a square root or an even root that is less than 0. That concludes this video. Remember, though, to look for more about functions, Part B.